Okay guys, in this video we're going to take a little bit more detail on our oxidation numbers and kind of how we do those. So in our last video we actually identified how we can pick oxidation numbers. Here's some additional practice for that you can do and all the answers to that. Okay, so you can do that on your own time if you want to do some additional ones. What I'd like to do is move on to our next slide and take a look at an actual equation and figuring out what is getting oxidized here and what is getting reduced. Okay, so to do that, we really need to look at what is happening to the oxidation states for each one of these elements inside our compounds. Okay, so we're going to take a look at number one, and we're going to start with number one and see what is going on there. Okay, so first thing we want to do is, if we take a look at number one, we have 3 lithiums, and we're reacting that with iron chloride, and we're making some lithium chloride and iron metal. Okay, so we balance this thing out, and it looks like this. Now, I didn't put the states of matter in here, but that's okay. We don't really need them for what we're doing right now. In terms of what we're looking at, it helps us a little bit, but not that big a deal. So lithium by itself, as a single element, has an oxidation state of 0. Okay, going over to our iron and our chlorine. Well, we have iron and chlorine in an ionic compound, which means that their charges will match their oxidation state. So in this case, chlorine is going to be a -1, and iron is going to be a +3 in terms of what we have here to balance out our charges. So their charges will also be their oxidation state here. On this side, our lithium chloride, again, it's an ionic compound, so chlorine is going to be a -1, lithium is going to be a +1, and our iron is going to become a 0. Okay? So the first thing I do is I take a look at my equation and say, wait a minute, chlorine was a -1 here and here, so chlorine really is not doing anything. So chlorine is just a spectator. So I'm going to get rid of chlorine because it is not doing anything in this reaction. Okay, so what we end up with is lithium and iron, and then if we break it down, lithium is becoming lithium ions, and iron is going from its ion form to becoming iron solid. Okay, so we go from a 0 to a +1. So 0 to +1 means you've given up an electron. So since we lost electrons, we are oxidized here. Iron went from a +2, so it is gaining electrons, so it gets reduced. Okay, so we look at this, we see very quickly that the lithium is oxidized, the iron is reduced. Now, to finish these half reactions, okay, so to take this to that next level, you say, how would we write up this half reaction, okay? So when we do that, we want to include everything. So let's start with lithium first. So we had 3 lithiums, and it is losing electrons, right? So it is going to lose electrons and become lithium, 3 of them, with a +1, which means there needs to be 3 electrons that are lost in this process because there was 3 lithiums here. Okay, so if you were to write the half reaction for this process, we have lithium turning into lithium ions plus 3 electrons are given up. Now the iron, if we go back to our equation, the iron, we only had 1 of them, and it started off as a +3, and it gained 3 electrons to become iron solid. That is a neutral or a 0. Okay, so these are the 2 half reactions, how we would write them up. So we see lithium half reaction. So this would be the half reaction for the oxidation, and this is the half reaction for the reduction. Okay, and that's how we do them. Now, you could do this for any type of equation as long as it's a redox reaction. Okay, if you go through it and you start assigning oxidation numbers and you realize that nothing changes its oxidation number, you do not have a redox reaction. And then what you have instead is either precipitation or you have some sort of other chemical changing that does not require a movement of electrons in terms of what those are. Okay, let's do one more and work out one more together, and then we'll give you guys the rest of them on this slide to practice. All right, so we go to the next one. And this one looks pretty simple to start because we have iron reacting with sulfur, and we're making iron sulfide. Okay, so the iron starts off as a 0, the sulfur starts off as a 0 because they're by themselves. When they're in a compound, sulfur is going to be, we have an ionic compound here, so sulfur is going to be a -2 for its charge, and iron is going to be a +2 for its charge, which means that the iron went from a 0 to a +2, so it has lost electrons again. So the iron lost electrons, so it was oxidized. So the iron ended up being iron 2 plus 2 electrons. The sulfur went from a 0 to sulfur as a -2. So the sulfur had to gain 2 electrons because it was gaining electrons to be reduced. Okay, so it went from a 0, these both were zeros, gain 2 electrons, becomes sulfur as 2 minus. Okay, so again, if we had to write up the half reactions, this right here are your half reactions. Okay, for the oxidation of the iron and the reduction of sulfur inside of these. Okay, one thing to be aware of is make sure when you start doing this, your first step really is to identify all the oxidation numbers on every element inside there. Once you do that, you find out what has a spectator, and those spectators we can get rid of, and we don't need them. So we go down to what we call as our net ionic equation. Get rid of our spectators, and then we figure out what has gained electrons, what has lost electrons, and then you just add your electrons in so that they match the amount of electrons shifted inside there. Okay, guys, 3, 4, 5, and 6 are additional practice that we will be able to do on this. Thank you.